exponential growth and decay, our basic differentiable function of t such that y is greater than 0 and y prime equals ky for some constant k, then its equation is y equals c times e to the kt, where c is the initial value of y and k is the proportionality constant. Exponential growth occurs when k is greater than 0, and decay occurs when k is less than 0. So start with example 1, solve the differential equation y prime equals 4x times 2 plus y. First, separate. So y prime divided by 2 plus y equals 4x. Integrate both sides. The left is going to be natural log of 2 plus y, and the right is going to be 4 divided by 2 is 2, and x to the 1 plus 1 is x squared, plus some constant c. It doesn't matter which side we have the plus c on. Rewrite that as an exponential. So that's e to the 2x squared plus c equals 2 plus y. When you add exponents, we can separate those as e to the 2x squared times e to the c. And e to the c is just a constant, so we can just make that one big constant. And then finish solving for y. Y equals c times e to the 2x squared minus 2. That's it. The rate of change of y is proportional to y. So that means rate of change would be y prime is proportional to y, means y prime equals. So y prime equals ky. When t equals 0, y equals 3, and when t equals 1, y equals 12. What is the value when t equals 5? So separate your variables. Y prime over y equals k. Integrate both sides. So that's left side's natural log of y. On the right equals kt plus c. Rewrite as an exponential. E to the kt plus c equals y. Since that's always positive, y can't be negative. Then that plus c we can put up front as an exponential, as a initial value, excuse me. And we know two ordered pairs. When t is 0, y equals 3. And when t is 1, y is 12. So we plug it in. That tells us that c is 3 when we plug in 0, 3. And then we go plug in the 12 and the 1. So we get 4 equals e to the k, so that means natural log of 4 equals k. So our equation would be y equals 3 times e to the natural log of 4 times t. Plug in 5, and we get 3072 about. Okay. How long will it take, excuse me, for 12 grams of radium to decay to 1 gram? Well, first off, radium-226 has a half-life of 1,599 years. So 6 is half equals 12 times e to the k times 1599. This is a college algebra problem. So a half equals e to the k times 1599. Natural log of 0.5 equals 1599k. So k equals natural log of 0.5 divided by 1599. Keep going with that. We want to know when there's 1 gram left. So we solve that, so we'll have 1/12 equals e to the natural log of 0.5 over 1599t. Take the natural log of both sides, and then we're going to divide by this lovely fraction here, which means just multiply both sides by 1599 over natural log of 0.5. Gets us about 5,732 years. An experimental insect population increases according to the law of exponential growth. There were 250 insects after the 3rd day of the experiment and 400 insects after the 4th day. This sounds like an example 2. So y equals c e to the kt. 250 equals c times e to the 3k, because that was after 3rd day. We also can solve that for c, so 250 over e to the 3k. Plugging in the 400, and we already know c is 250 over e to the 3k. Can plug that in. These two same base. When we divide, we would subtract, so that would be 250 e to the k. So 1.6, because that's 400 divided by 250, equals e to the k. So natural log of 1.6 equals k. Figure out c. So we plug that in, e to the 3k. So 250 divided by e to the 3, natural log of 1.6. That gets us about 61 insects. Okay, 6 months after it stops advertising, manufacturing company notices its sales drop from 200,000 to 160,000. The sales follow an exponential pattern of decline. What will it be after another 3 months? So in a total of 9 months. Got our first ordered pair. And we know it's exponential. Plug in what we got. Solve for k. So dividing, we get 4/5 equals e to the 6k. Rewrite as a log, and then divide by 6. So that's what our k is. So we've got that. Now just plug in 9 months, because that's another 3 months after the 6 months. We get about 143,109 is where it'll be at. You're making a stew. Okay. When you take it off the stove, the temperature of the stew is 180 degrees Fahrenheit. Room temperature is 74 degrees. After 5 minutes, the stew is cooled to 155 degrees. How long will it take the stew to cool to a serving temperature of 95 degrees? Well, here's our basic rate from the textbook. dy over dt equals k times y minus 74, because subtracting off the room temperature. Separate our variables. Take the integral of both sides. So we get natural log of y minus 74 equals kt plus c, and we can just rewrite that as a exponential and move the 74 to the other side. Now plug in what we know. At time 0, it's 180 degrees. So that gets us c is 106. So now we've got that. Now we need to figure out what k is. So we plug in the 155 at 5 minutes. And subtract off the 74, we get 81 equals 106 e to the 5k. Divide by 106. Take the natural log of both sides. Divide by 5. Now we continue. So we've got our k. Plug it in. Notice I just keep writing it versus simplifying. And, well, not simplifying, but writing a decimal rounded. And we want to plug in when it equals 95. So subtract off the 74, divide by 106, take the natural log of each side, and then we're going to multiply by 5 and divide by natural log of 81 over 106. That gets us about 30 minutes.